Hello everyone, my name is Sahil,
My name is Manan.
and today we are presenting on our project based on biometric payment system using fingerprint authentication. So why are we making this project? Introduction. Biometric technology is rapidly advancing and bringing transformative changes across various industries. From healthcare to finance, biometrics is enhancing decision making and automating tasks. This evolution is paving the way for smarter, more efficient systems that will redefine the way we live and work. Digital payments need to be fast, secure, and user friendly, and that's why we have used biometric fingerprint authentication. Traditional methods like cards, pins are prone to thefts or misuses. Objective is to propose a fingerprint based biometric system for secure and rapid payments, and they are mostly ideal for coffee shops and retail outlets.
The UPI plus fingerprint based payment system introduces an added payment layer to the traditional UPI process, making it more secure and user specific. Here is a detailed comparison between normal UPI system and the UPI system using fingerprint. First, security. In normal UPI system, we have security level, medium security level, whereas in UPI system using fingerprint, the security is high. In normal UPI system, the user verification is done using PIN slash OTP, whereas in UPI with fingerprint, we uses fingerprint as a biometric trait for identifying the user's identity. In case of risk and fraud, the normal UPI has higher risk as anyone who knows the PIN and OTP can access and do transaction. But in case of UPI plus fingerprint, uh, everyone has unique fingerprints. So only the authorized person can do the payments. Now talking about the convenience, in normal UPI, we have to follow some steps for doing the payment. But in case of UPI plus fingerprint, we just have to provide our fingerprint and the payment is done. In the case of non-repudiation, normal UPI cannot verify the source of the OTP or PIN. Whereas UPI plus fingerprint, we have to provide the fingerprint so the source is verified. Now we'll be explaining the working of our project. So in the first step, we will be doing user registration. In this, we are taking input a fingerprint image named sahil.jpg, and the output is fingerprint is processed and features are extracted. User is saved in the database with fingerprint features, and user Sahil is registered successfully with his UPI ID. Both If the both fingerprint matches, then payment is successful, balance is updated, and matching score and transaction details are displayed. If the both images doesn't match, then payment is denied due to fingerprint mismatch and reason for failure is shown.
Now I am going to explain the implementation of our project. First, database setup. SQLite database is created to store user details, name, mobile, UPI ID, balance, and fingerprint features. Second, pre-processing. Read the fingerprint image in grayscale, enhance using fingerprint enhancer library, resize to a standard dimension, binarize using OSU thresholding, skeletonize to highlight fingerprint ridges. Third, feature extraction. Extract hog, a histogram of oriented gradients, features from the skeletonized image. These features represent the fingerprint's unique pattern. Fourth, fingerprint matching during payment. Extract features from the verification fingerprint, compare with the stored features using Euclidean distance. If the match score is below threshold, for example, we have used a threshold of 10 in our project, so it is considered a match if it is below 10. Fifth, payment pre-processing. If fingerprint matches and the sender has sufficient balance, then the amount is transferred and both user balances are updated in the database. Sixth, performance evaluation. ROC curve and accuracy are calculated using genuine and imposter scores. 7. Visual output. Displays fingerprints and matches results visually using matplotlib. So this was all about our presentation and now we will explain the code. We have used multiple libraries in our project. The CV2 library is used to read the raw fingerprint image. NumPy library is used to plot the curves, and matplotlib is also used to plot the curves. SQLite 3 is used for database, and fingerprint enhancer library is used from a GitHub page, and which enhances the fingerprint and helps in the feature extraction process.
Now we have created a function named create underscore database. In this, we will be storing name, mobile number, UPI ID, balance, and fingerprint of the person. Then next function is created for image enhancement and feature extraction. In this, we are doing the pre-processing of the image taken from the input. The next function we have created for user registration. Uh, in this, we will be taking name, mobile number, UPI ID, balance, and fingerprint path, and we will be storing it into our database. The next function we have created is for matching. In this, we will be matching the input image and the stored image. We have created a function named process underscore payment in which we are taking input as sender's UPI ID, receiver UPI ID, amount, and verification image.
So now we have created a function evaluate model, and in this we have calculated the ROC curve, the FPR, TPR, and accuracy for our model. Now the next one is demo workflow. So this is the basic workflow in registration. We have registered two users. The first one is Sahil, and the name, phone number, UPI ID, and the amount and the path of the fingerprint image is stored. And the second user is Bob. Next is process payment. So we are processing a payment from Sahil to Bob. Both the UPI IDs are mentioned and the transaction amount is also mentioned with the image path. The third one is evaluation. So in evaluation, we have done skeletonization, feature extraction for the fingerprint images and calculated the genuine and imposter scores to evaluate the model. And we have used matplotlib to plot the ROC curve. Now next is registered payment versus payment fingerprint. So we are taking input at two stages. First is that we are registering the fingerprint of the user, and then we will match that registered fingerprint with the fingerprint that the user is giving during the payment stage. So for that we have used threshold values to calculate our match score, and this is the output. So this is the image of original image taken from camera of my fingerprint, and this is how the it looks after feature extraction. So it is 100% match because we have used independent samples, and payment successful is shown. The balance is updated, and the ROC curve is plotted as shown. So this is the output of the registered fingerprint and payment time fingerprint. Both are same, so the match score is 0, and we have calculated this using the Euclidean distance. So whenever the distance is less, it is a match, and the payment is processed. So now in the next code, we have taken an imposter image so that we can show that if both images are different, it does not match. So here we have used match score less than 10 to set a condition for showing the imposter image, and the output is as follows. So this is verification fingerprint. This was the original fingerprint which was matching, and now when I uploaded the imposter image, so it shows no match, and we can see the ROC curve for the matched image. Accuracy is also reduced to 50%, and the imposter match score is shown as it is above 10, so it does not matches. We have used a fingerprint enhancer library from a GitHub repository to enhance the fingerprint images and for feature extraction. So it uses Gabor filter, Otsu thresholding, skeletonization to enhance the image. Thank you.
Thank you.